In this video, we will be doing on trigonometric graphs. So before we start, let us just look at a normal graph. We have the y-axis and the x-axis. So let's say I just have a graph like that. Okay, whatever is shown here on the x-axis, for example, if the value of x is, let's say 3 here, you can see that maybe the value of y will be something, alright? Then maybe like when we move along the graph, as the graph goes maybe 4, we get another value, correct, of y. So we say that y is a function of x. Okay, this doesn't mean that f times x, it just means this f just means it's a function of x. So it can be like maybe 3x squared plus 2x minus sine square x. For example, things like that. See, so the only thing that changes is x. And depending on how x change, the value of y will change. Okay, but I mean this is just a random graph. Probably there's no equation to it. Okay, so knowing this, we're going to take a look at how graphs actually work. And I'm going to use this software called Graph. Alright, it's made by this guy, whatever. It's a free software. Okay, so you can download it online to know about graphs. Alright, so first let us take a look at the most basic trigonometric graph, which is the fx, okay, which is y equals to sine x. See here? So this is a graph of y equals to sine x. Okay, as you can see, for trigonometric graphs, it goes on forever and ever, but in a repeated fashion. Right, if I zoom out, okay, you can see that it just goes on forever and ever. See, the graph just goes on in a repeated fashion. Okay, and it repeats about 360 degrees. Okay, in this tutorial, we look at the graphs in radians mode. So 360 degrees is 2 pi, which is here. Okay, so the graph goes on like this, and then on and on and on. For the sine graph, things to take note. First, it starts at 0. So sine of 0 is 0. Okay, and it goes like this. It goes back to 0 at pi, which is 180 degrees, and it goes downwards back to 2 pi. Okay, so that's just a basic sine graph. Okay, it's good for you to go and take a look at where the peaks are. Okay, the peaks are here. You can see pi over 2, which is 90 degrees, and the value of that is 1. Okay, let me just change the axis a little. So the y-axis maybe taking it 1. Okay, so you can see that actually it's 1 here. Okay, and as you go down, you see it's a negative 1 here. Okay, and back up to 0. So for sine graph, the maximum values is 1, negative 1. Okay, we call that the amplitude is 1, meaning the difference from the middle. See, the biggest difference from the middle is 1. Okay. Next, we'll take a look at the cosine graph. So let's do it. Cosine of x. Okay, and just take away the sine graph. And we can change its color, right? So the sine graph, I'll put it in red. No, I mean the cosine graph will be in red. Okay, so this is the cosine graph. Okay, for the cosine graph, okay, sorry, let me just change it to green, because I'm going to compare the sine and cosine graph later. Okay, it's a little light green. This green. Okay, so as you can see, for the cosine graph, okay, again it repeats forever. Alright, it repeats forever. And where does it repeat upon? 360 degrees again, right? So here, you look at this. So kind of starts at 1, goes down, back up, and ends at 2 pi. Okay, so it's a little different from the sine graph. As you can see, okay, the sine graph is the pink one. Okay, sine graph starts at 0, it goes to pi, ends at 2 pi. While the cosine graph is starts at 1, right, and it goes down and comes back up. Okay, so that's the cosine graph. And note that the reason why graphs repeat at 2 pi is because, remember in the axis we draw, you remember in trigonometry where we draw the angle thing, yeah, when your angle, right, when the angle goes 360 degrees, it repeats itself, correct? So see, it repeats itself. So that's why everything past 360 degrees repeat itself. Okay, so it's in cycles of 360 degrees. Okay, so back to the graph. Okay, next we're going to take a look at the tangent graph. And the tangent graph is actually very much different from the sine and cosine graph. See this. Okay, so same thing, it repeats at 2 pi. Okay, so you can see at start it goes up here, and then it comes back. So it's kind of like you see, at pi over 2 is asymptote. It means at pi over 2 the value of tangent x is like infinite. Okay, it's like there's no value to it. So you type in your calculator tangent of pi over 2 or tangent of 90 in whatever mode it's relevant. So tangent of pi over 2 is in radians. Here when you type it in your calculator you get a math error, which means it's too big. Okay, it's infinite. Alright, so up here comes back here, ends at pi. Okay, and goes up again, ends at 2 pi. Now you might ask, doesn't it repeat at pi? I mean, okay, that's technically logical, but we always look at things from the 0 to 2 pi. Okay, so we just take it as the repetition is from 0 to 2 pi and then repeats and repeats itself, as you can see. It looks like waves, right? Okay, so what's happening? Okay, hey, wait a minute, what's happening? Okay, so now if you take a look at this, okay, I'm going to change the tangent graph to another color, purple. No, it's the same color as that, red then. Okay, you can see that, remember that tangent x is equal to sine x divided by cosine x. Now, at points where, if you take a look here, I'm just going to zoom it in. Okay, look at this part. Pi over 2. When x is pi over 2, cosine x is 0, right? And this is why when tangent x is infinite here, because sine x divided by 0, whatever sine x is, will give you infinity, right? So that's where one thing about it. Okay, and as you can see, cosine x is 1. Okay, when x is 0, and sine x is 0 when x is 0. So tangent of 0, which is here, is actually 0 also, because sine x is 0. So 0 divided by anything, 0. Okay, so the tangent graph is really a beautiful equation of sine x divided by cosine x. Right. So next we're going to look at how changing how linear change to the graph can make the graph different. So what I mean is this. Now we have graphs that are y equals to sine x, right? What happens is sometimes you have graphs like that. Y equals to a sine of maybe bx plus c. Now a, b, and c are constants, so a can be constants mean the numbers like 1, 2, 3, 4, 5, right? Here all can even be decimals or anything, whatever. So what happens is when we put in things like that, maybe like y equals to 3 sine of 2x plus 5, how will the graph shift? Okay, and I'm going to explain this part now, okay, which is going to be a little well, not easy to explain, but I hope you understand. Alright, okay, but it could be really easily understood. Alright, so first we just look at sine x first. Alright, since whatever applies to whatever we do to this, to sine x, for example, we do something like that, you can apply the same method, absolutely the same method, to tangent and cosine. So for example, y equals to 3 cosine 2x plus 5. It's whatever this function is, cosine, sine, or tangent, we can apply the same concept and get the graph. Okay, so the purpose of this part of the tutorial is to help you visualize and understand how the graph will change as we change the values of a, b, and c. Okay, for the normal y equals to sine x, you realize that a is actually equals to 1, b is 1, and c is 0, correct? because this is y sine x is the same as 1 times sine x 1 times 1 of sine 1x, okay, plus 0, right? I mean, if you simplify, sine x, right? So now whatever a is, all right, let me just delete everything. Whatever a is, whatever a is actually the amplitude. Okay, so amplitude, remember I said before, is the difference from the middle. So for example, the middle here is 0, right? Okay, later you'll see that the graph, the middle might not be the 0, okay, when we change the value of c. So in this case, let's look at basic y equals sine x. Spin in. Okay, so remember that this graph repeats at 2 pi. Okay, just remember that. That has to do with the b. Okay, but now we're going to do just the a. So when I change, for example, y of x, I change it to y equals to 2 sine x. We see what happens. Okay. Yep. Okay. What happens is it still repeats at 2 pi. Okay, it still repeats at 2 pi. But the maximum value now goes up by 2. Goes from 1, just now it was 1, now it's 2. Okay, so we can just add in a function y equals to sine x, and you see the difference. See, so y equals sine x, this blue, alright, this is the normal one. Okay, so what happens is all the values are multiplied by 2, because that makes sense, right? When we change y equals to sine x to y equals to 2 sine x, I mean the value changes, right? I mean it's just 2 times more. So if sine x is 0.5, so now 2 sine x is 1. So every value of y goes up by 2. So of course the maximum goes up by 2 also, right? Since this is 1, it's 2. Alright, so even if we change this to 3 sine x, take a look. It just means that the amplitude, everything that changes multiplies by 3. So from here, you multiply 3 is this. Here multiply 3 is this. Here multiply 3 is this. Here multiply 3 is this. Alright. Okay, now let's take a look at what happens if we change the b, value of b. Okay, but of course without changing the value of a. Okay, so now we can take a look what if we change the value of b. Alright, and b is, so for example now we look, so first we look at what y equals to 3 sine x is, right, which is what we did now. Now we're going to look at what happens if y is equals to sine of 3x. Okay, and take away this y equals sine 3x function. Okay, let's take a look at what y equals sine 2x first. Okay, now what you see is this. So y equals to sine x, if you see here, it's a sine thing, right? It's this long thing here. But when you put y equals to 2 sine x, it becomes half. So instead of repeating at 2 pi, it repeats at pi. Okay, now so one good way to remember is whatever this b is, okay, let's say b is big, let's say it's 2, right? It means there are 2 cycles from 0 to 2 pi. So initially sine x have 1 cycle, right? Up, down. Okay, but when you change sine y equals to sine 2x, it means there are going to be 2 cycles in from 0 to 2 pi, which also means that each cycle is half, means initially it was 2 pi, now each cycle is only pi. Okay, so the larger the value of this b, y equals to sine 2x, y equals to sine bx, the larger the value, the more the repetition, means the more the graph will compact. Okay, so let's say I did this to 3x, take a look at what happens. You see, now there are 3 cycles, so 1 cycle ends here, 2 cycles, 3 cycles. Okay, so similarly, okay, so now let's look at the last one, which is plus c. Okay, now before that, I'm going to explain to you why there's so many cycles when you change this. Okay, because you see now, let's say we have in the original sine graph where sine of pi over 2, I mean y equals to sine of pi over 2, and at pi over 2 here, right, the original sine graph, take off this. Okay, you see that at pi, y equals to pi over 2 and sine pi over 2, they're 1, right? Now, when you have a graph, so this is what sine x. graph of sin x. Now when we have the graph of sin 2x, it means that for you to get the same value of y, right, to get the same value of y, I'm going to make the y equals sin 2x appear here. To get the same value of y, because now it's a sine 2 of something, correct? Sine times 2 of something, right? Now, before this, we only need to times by pi over 2. But now, to get sine 1, we need what's inside to be also pi over 2, right? But because there's a 2 inside, we must make this even smaller, which is pi over 4, so that we can get the same value of 1. So in this case, instead of having the graph at pi over 2 here to give you 1, see this sine thing, now my value must be smaller, right? My x must be smaller, so that I can get back the value of 1. So to get back a value of anything doesn't just be 1. I use 1 because 1 is easier to see, okay? So to get any value, right, to get back the same value of anything, your x must be 2 times smaller. Alright, so that is why the graph actually repeats 2 times. 1 time, 2 times, okay? Okay, so we can see that, okay, now we actually saw that b of x, changing the b changes the amount of repetition, okay? And lastly, we're going to take a look at c. Okay, this is when, c is just so much simpler because it's just so simple. Okay, so for sine y equals sine x, when you add a c, for example, I'm going to insert a graph. Insert this. Okay, so when I put a graph of sine x plus, let's say, 5, well, what happens is the graph just shifts up. Makes sense, right? Because take a look, let's say I have y equals sine x. When I want to make it into y equals sine x plus 5, so whatever the value of y is, which is just the same as sine x, but added 5. So if sine x is 0.5, this is 0.5 plus 5. So what happens is the value of y just goes up by 5. So let's say we have a value of 1 here, now it goes up by 5, 6. Value of 0 here goes up 5, it's 5. Any value here, what's this, it goes up by 5, which is the new value. So the plus c just shifts the whole graph. Now, it shifts the whole graph. When I mean the whole graph is this graph, okay? It shifts this graph up because you can see that this addition only is added to this, right? Added to this. Okay, it adds a sign, so it shifts this whole thing up. Okay. Okay, now one more question is, what if we have like numbers like this? What if a is less than 1? So like if y equals to 1/3 of sine x, or y equals to sine of 1/3 of x, or y equals to sine of x, I mean plus 1/3 just is the same, right? Just adding 1/3. Okay, but more importantly, this too. So just okay, so now remember that if let's say we have y equals to sine of 3 sine x, right? Okay, so sine x is the cyan one, and purple one is y equals 3 sine x. The amplitude increase multiplied by 3, right? So now if I have we change it to 1/3. So now instead of the amplitude being at 3, now just 1/3, it just becomes 3 times smaller. Okay, so in fact this a, right? Why does a sine bx plus c? Now this a is just a scaling factor. It scales the sine graph. Okay, it doesn't scale this. It scales the sine graph. So if a is more than 1, it makes the sine graph taller. So it's fatter, taller. Okay, but if the sine a is smaller than 1, which is of course like this, it makes the graph shorter. And if a is negative, okay, now if a is negative, what happens is it flips the graph. Okay, just so it's a negative of 2x. Okay, so now it just flips the graph, so whatever was positive was now negative, and of course amplitude changes. So for A, the magnitude of A, meaning how big the number, okay, so how big the number is. For example, if A is, whether A is 3 or negative 3, this the magnitude is actually 3, right? And so the magnitude of A makes the graph like taller or shorter, okay? While a negative sign, just if there's a negative sign, the sign graph just flips, okay? Just flips, else it doesn't flip. Yeah, so that's how you change the graph according to y equals to sine, according to the scaling factor, okay? And for B, what if its sine equals to 1/3 of x? Okay, in that situation, you're going to see this, okay, the purple one, but we're going to edit it and make it sine of, okay, maybe half of x. So remember, when we were talking about sine 2 of x, there were 2 repetitions from 0 to 2 pi, right? But now, when you do y equals to sine half of x, you can see that, maybe I can zoom it, okay, I'm going to shift it more here, and zoom a little, I don't know, change the axis, okay, y-axis, maybe -2, okay, yep, so you can see better now. Okay, so sine graph is the sine, this is the sine graph. The sine of half x is this. So now the graph is get longer. Now just now the graph got shorter, right? So let me show you. Y equals to sine of 2x. And sine of 2x is actually the maybe I just put it as green. Okay, so you can see that the sine of 2x as compared to sine x is sine 1, sine of 2x is flattened, right? As I've explained just now, it's shortened. But now for the y equals to sine of half x, it's longer. Okay, this is the y sine of 0.5x. Okay, so this you can see it as 0.5 FO, that's 0.5 per cycle. Okay, so it gets longer. And how much longer does it get? 2 times. Okay, because this is 0.5 and it's so it gets 2 times longer. Okay, so knowing this, we want to see how the coordinates change. Okay, I mean you understand how sine a of x changes, right? The value just get multiplied by what a is. Okay, so if a is 3, so let's say we go back to this. Okay, so in this situation, when a is 3, the y-axis coordinates will be multiplied by 3. Okay, even if a is -2, the y coordinates will just be multiplied by -2. Okay, that's a scaling factor. Now for this one, where we have the lots of repetition, I would say the coordinates. So for example, initially where at y is 0, okay, let's say y is 1, you have pi over 2, right? Because this is sine x, the sine 1, and then y equals sine 2x, you have pi over 4. So I would say that the coordinates of x in the new graph is just divided by b. So if in this case b is 2, correct? Because looking at the graph of sine 2x, so b is 2. So the coordinates of what originally was in sine x are now divided by 2. Okay, which means so for example, let's say I have this point here, okay, where sine x, y equals sine x, it's 1. The new coordinate of where 1 is, so wherever 1 is, the new coordinate of it is equals to pi over 2 divided by 2, okay, which is pi over 2 divided by b, because b here is 2, correct? Similarly, if I'm looking at 0.5x, originally, where value of 1 is pi over 2, right? Now, because b is 0.5 here, the new coordinates of where 1 will be, the new x coordinate where 1 will be, so now look at this, y equals sine x, right? It's here. So the y equals sine x. For y equals sine x, the x coordinate for where 1 is, the x coordinate for where the y coordinate value of 1 is, okay, y coordinate value of 1 is, the x coordinate value is pi over 2. For the y equals to sine 0.5x, the coordinate now is pi, correct? See, 1 is pi over 2 here, 1 is pi here. So the new coordinate is equals to pi over 2 divided by b, where b is 0.5. So pi over 2 divided by half is actually pi. So that's how you find the new, that's how you know the scaling factor, alright? Okay, and lastly, when you add, just the sign, when you do something like that, you can see that actually cancels off, goes up, right, like that. So when you add a c, when sin x plus 5, the new values of the y coordinates just goes up. Okay, so what you really need to understand here is the way the graph changes as you change a, b, and c. Okay, so now this applies absolutely the same to cosine x. Okay, it applies absolutely the same. So I'm going to show you here. Draw cosine x. Look up. So if I insert a function of, let's say, 2 cosine x, look, same thing, magnitude changes. So it becomes 2 times larger. Green. Let me try green, okay? Yeah. Pardon. Okay, so look, it's 2 times more. Now again, if I change the 2x, it becomes 2 times flatter. See repetition 2 times. In one repetition, here from 0 to 2 pi, now it becomes like that. 2 repetitions. Same thing if I'm going to shift it up. Goes up. Alright, so let's try tangent x, okay? Okay, so the basic one will be 2 tangent x. Okay, you see the magnitude. Okay, now the original tangent x is the pink one, alright? Let me just zoom a little. Okay, the original tangent x is the pink one, and when you multiply it by 2, it becomes, you see the value is 2 times more. So for example, at pi over 4, where 1 is, yeah, pi over 4, you have 1 in this one, correct? But now in the 2 tangent x, you get 2. So the value is 2 times more. Okay, it's still the same. It doesn't look as nice, but it's still the same. Okay, it's multiplied by 2. At pi over 2, because it's infinity, I mean infinity times 2 is still infinity. Okay, so it's the same. What if I change this tangent 2x? You see that it just repeats twice. So to zoom out to show you. Okay, originally the pink one, look at the pink one, okay, pink one. How many repetitions are there? 1, 2, from 0 to 2 pi, right? So 1 and 2 ends at 2 pi. Adding in now, it goes 1, comes back. So the green one, right? Tangent of 2x, it now shifts in. You can see that there's 1 here comes in, 2 here comes in, 3 here comes in, 4 here comes here. Okay, so it's repeated 2 times. And lastly, when we're going to shift it up, what happens is it just goes higher. So green is the new tangent, right? So I'm gonna shift. See, can you see it? Can you see the pink one? Now it's shifted all the way up 5 times. I mean not 5 times, by 5. So whatever is here from 0, it's here. Now when you come up here, it's 5. Okay, so this is the shifting of the graph. All right. Yeah. So I mean, this applies to all graphs, all right? Sine, cosine, and tangent for the trigonometric graphs. So you don't really have to worry about it, all right? So remember, in summary, for y equals to sine x, a sine bx plus c, whatever this can be, cosine or tangent, it doesn't matter, okay? Same. Okay, a changes how much the scale is. Okay, bad drawing. Okay, b, this is how a changes. B changes the repetitions. Something like that, alright? And c shifts the graphs up. Okay, so now we're going to do some examples where we have not just one change of variable, a, b, we can have multiple change of variables. So what we have been doing is we have been separating the changing variables, right? So we separate y equals 3 sine x, done. Y equals to sine 3x, done. Y equals to sine x plus 5. What if we combine everything? We get y equals to 3 sine 3x plus 5. Okay, to do this, it's really simple. First, look at the b. Sine 3x tells you that it will be repeated 3 times. So it's good to start with b first, okay? So I'm going to use sine, for example. Zoom in. Zoom in, 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 zoom in. Okay. Shift. Okay, so first what you do is find the repetition, sine 3x. So I know that it's sine 3x, there will be 3 repetitions inside. Okay, so even if I do not have a graphing function, if I know that this is sine x, the black one is sine x, my new graph, with just my brain, I'm going to do it. Sine 3x is going to use 3 times. So you just calculate, alright? It's something like that. And the coordinates, of course, are shifted since divide by b, right? So what maybe if see now one repetition was the black repetition ended here, which is at 2 pi, correct? Now I'll know that this is 2 over 3 pi, because this is where the original graph, when I repeat it 3 times, I have to make it 3 times smaller, right? So this is 3 times shorter than the value of 2 pi. So 2 pi, when you make it 3 times shorter, is 2 over 3 pi. This will be 4 over 3 pi, and this is 2 pi, which is 6 over 3 pi. Okay, that's what I know. The first thing I know is this. Then I look at the, so after I look at b, I look at a, which is going to shift out by, no, not shift out, the value of y from the sine x graph will need to be increased 3 times, correct? So it gives me this new graph where the values are 3 times more. Just a rough drawing, okay? So the values will be 3 times more. Now at points at 0 must repeat, because 0 times 3 is 0. Okay, so the points where the zeros appear, they are the same. Okay, so I get 3 times more. And lastly, you can see that this 5 shifts the whole graph up, right? So only after I scale the graph by 3, then can I shift the graph up by 5. So when I shift it up by 5, maybe it's here, so it goes like that. Something like that, alright? Okay, so where this is 5, this is 0. Okay, so the whole graph shifts up by 5, alright? and if you look this is what I say, right? Okay, let's see whether I'm right. Okay, so I'm gonna do 3 sine x. What's this? 3 sine 3x plus 5. 3 sine 3x plus 5. And I'm right. Alright. So this sums up the whole thing about graphs. Okay, the thing is, in questions, it will be a little more tricky. Okay, they'll be asking the questions in different ways. But what is most important is you understand this concept, okay, of how you compact or you lengthen the graph, you know, things